Hey, this is lesson 3 of Unit 1, Topic 1. This is serving up symbols, which is all about writing meaningful expressions to represent things using let statements, which is items that they've already given you. So in this first warm-up, we're going to be substituting. We're going to be taking what they've given us for A, B, C, and D, and substituting it in to find what the expression represents. So in this case, A is -3. So 2 times -3. You might want to keep a calculator handy on this, because especially with these fractions involved. 3 times b, b is 1/2. 2 times -3 is -6. Half of 3 is 1.5. And when you add them, you can use a calculator. You're actually going to get an answer of -4.5. Question number 2, 4 times c. c in this case is 3/5. And I need to write a little bit neater so that I don't make a mistake like I did in the last video. And add d, which is -4. I'm going to put it in parentheses just so that it stands out so the negative sign is not next to my plus sign, which can be a little bit confusing. Now, I'm going to multiply the whole number times the numerator. 4 times 3 is 12. And I'm going to reach for my calculator right here, TI-83 plus or any TI-84. Actually, in this case, you can use any calculator because we haven't done graphing yet. So 4 times 3 is 12. 12 divided by 5 is, and this calculator is having some issues. Oh, let me grab another one. Oh, there's the announcements. 4 times 3 is 12, and 12 divided by 5 is 2 4/10. Now I've converted this to a decimal. And add that to my -4. So if I add that to -4, it gives me an answer of -1 6/10. Question 3, we have 3 times b, which is 1/2, over, which means divided by, -4, which is d. 3 times 1/2, like we did earlier, is 1.5, and 1.5, or 1.5, said incorrectly, it's actually 1 5/10. Divided by -4 gives us an answer of -375 thousandths. And I just wrote something different than what it said, 375 thousandths. Okay, so that's substitution, which kind of gets us ready for what we're going to be doing in this lesson, which is going to be doing some substituting of what things mean in order to write meaningful expressions. Before we can do that, though, we have to talk about some of these algebra words that you might not have done in quite a while. So we're given an expression here, and we're being asked, what do these words, what do they represent? So in this case, a polynomial just represents multiple things all combined together that cannot be added together. Polynomial. Many parts. Poly really means many. Monomial means one. So this x to the 9th power is one part. This 4/10 is called a constant because it's just the number, is all one part. Any number that's being multiplied by a variable, in this case, is called a coefficient. That word is actually not here, but technically 1/2 will be the coefficient of the x to the 9th. An equation just means that it's equal to each other. A constant, as I had already mentioned, is just a number by itself. Factor means something that's being multiplied. This is a dilation factor is actually what it's called. An expression would just be part of this. This part would be an expression because it's all one piece, just kind of like a polynomial, but it's not equal to anything. So this polynomial is actually equal to this monomial over here. So that's a little bit about the vocabulary. So then we're given all these let statements. So in this video, we're given all of these symbols. I'm going to stretch this out a little bit so we can see what they are. Oop, that'll just have to do. And each one of these symbols represents one of these things. So there's tons of let statements that have to do with the cafeteria. So what we're going to do is we're going to write meaningful expressions, and we'll figure out what expressions that they're given to us. So by the end of this lesson, you can write your own meaningful expressions. Using these symbols, what would the expression G plus B represent? So that's the girls plus boys. So basically that represents the total amount of people that go to lunch. And C times P, if you go back, C stands for the number of classes per lunch, period, and C times P is the number of lunch periods per day. So that would give you the total amount of classes over the entire day. So if you're dividing the total amount of students per day divided by the total amount of classes per day, that would give you an answer that would represent the number of students per class. per meaning division in this case. So that would tell us that there's maybe like 25 students per class, or 28 or 30, or whatever it might be that you think would be a normal one. Using these symbols, what do you think the expression S plus F plus L would be? S is the total amount of students that buy lunch in the cafeteria, plus F, which would be the total number of food servers in the cafeteria. Okay, so if we add those, that's like all the people in the entire cafeteria. That makes sense. But then it asks us to add L, and L represents the number of lines. Now, you might be thinking, why would I add students plus workers plus lines? What does that answer mean? It means nothing. That actually doesn't make sense whatsoever, and that's kind of the point of this. If I added the first two, that would be meaningful. That would be the total amount of people in the lunch in the cafeteria. But once you add lines to people, one line plus one person makes two what? I mean, that makes no sense. So that's the whole point of this. So you're supposed to write meaningful expressions, ones that actually do make sense. So for instance, if you're trying to figure out the total amount of items you buy at lunch, all you have to do is add NE plus NS plus NB. That would be an example you could have come up with. NE plus, that's number of entrees, plus number of beverages, plus number of, I forgot what the last one was. B for beverage, S for side dishes. That's what I forgot. So NS for side dishes. So what would that represent? That would represent one full lunch, because that's the amount of items you bought in for each of the three items. That gives you one full lunch combined. All right, so that's basically what this lesson was about. There are some other things that we did. We also previewed writing some equations, which we've done in the past. So you probably want to know about this homework that you had to do. So basically this was kind of the same as you've been doing, only you're justifying using the properties now, which most of you saw last year in IM anyway. So if you have 3 times x equals 15, you know that normally you would divide both sides by 3. And the reason why you're dividing by 3 is because you do the opposite operation, because 3 divided by itself is 1, leaving you with x equals 5. Now, what property was that? That was the division property of equality. All right, and my writing pencil, as you can see, is acting up just a little bit. This one down here, you're going to subtract 1 1/10 from both sides. And once again, you can use your trusty calculator. Negative 1 6/10 minus 1 1/10. If you're not good at your integers, then make sure you use a calculator. And that gives you an answer of negative 2 7/10. And this would be the subtraction property of equality. I'm just kind of abbreviating here. Subtraction property of equality. And basically what that means is equality means equal. You're doing the same on both sides. And you're doing subtraction on both sides. And the reason you're doing subtraction is because it's the opposite of addition. Over here, you've got minus 10, so you're going to do the opposite, which is add 10 to both sides, which is going to give you x equals 12. And the justification would be addition property of equality. For this one down here, you've got to do 2 steps. Minus 6 3/10 on both sides. Once again, you got your calculator you can use, or maybe you can do this in your head. It happens to be 4 4/10. So that gives you negative x equals 4 4/10. But then that doesn't give you the answer of x. So you want to divide both sides or multiply both sides by negative 1 to get the x by itself. So x is actually negative 4 4/10. So you actually did 2 properties here. So I'm not writing here because I'm trying to save time. This video is already 9 minutes long. Subtract, this is subtraction property of equality, and then down here we did either division or multiplication property of equality. It doesn't matter which one that you use to prove it, because technically they're going to give you the same answer. All right, so that's another day and another lesson. Have a wonderful day. Thank you. Bye.